Zoom screen. Yes. So, okay. Share. Okay. We have already seen these. That screen. Now we already discussed about these. The two-wire DC system with me to discuss about this as well. Who is that guy? Mute himself. Okay. Today we will see not this one, not this one. We will only see. Okay, see this one. Single phase two-wire AC system with one conductor earth, right? Single phase. That means not three phase. This is single phase. Now here you will have only one exciter. You have one line and you have one neutral. That's it. So I4 will go, the current will go, the current will come. Since it is the number 4, that's why there is I4, nothing else. So figure that shows a single phase two-wire AC system with one conductor at the maximum voltage between the conductor is Vm, so that the RMS value of the voltage between them is Vm divided by root 2. Because the total voltage is Vm, that is a peak value, and so the RMS value will be Vm divided by root 2. Assuming the load power factor B cos phi, obviously because it is AC, there will be a power factor cos phi, lead current I is equal to P divided by Vm by root 2 cos phi, because obviously P divided by V cos phi, and V is actually RMS, so V is equal to Vm divided by root 2. So the root 2 will go up. So your I is equal to root 2 P Vm cos phi, this one. Okay. Now let A4 be the area of cross section of the conductor. Now you have to find out the line loss. The line loss W is equal to 2 I4 square R4. Why 2? Because you have two conductors, for this one and this one. And the line loss will be 2 I4 squared into R4. And 2 is 2, I4 is this one, root 2P divided by Vm cos phi whole square, and R4 will be rho L by A4. So this obviously we know, R is equal to rho L by A, rho L by A4. Again, what we got actually the square will become 4, the square will eat up the square root. So 2 and 2 is equal to 4. 4P square rho L divided by Vm cos phi into A4, right? Okay, no, not Vm, actually Vm is square, cos square phi, A4. So take the A4 and take the W and make the intersection, what is that? Make the exchange, okay? Exchange the A4 and W, and when they change their position, the cross section of area A4 is equal to 4 P square rho L cos square phi W Vm square. Know it. Now the volume of conductor material required will be 2A4L. Why? Because the volume will be A4L, because it is two conductor, so 2A4L. Now we know the A4, put it there. The final value will be 2 divided by cos square phi into 4p square rho L square divided by W Vm square. Here, why we make that separated? Because we want to make it as look as K, or looks like K, right? Because K is 4p square rho L square divided by W Vm square. So that's why we separated them. 2 divided by cos square phi divided by W Vm square. So the final value is 2k divided by cos square phi. Now here you can understand the volume required for single phase AC is much bigger. Why? Because cos square phi will never be more than 1, because the final highest value of cos is 1, right? So if you make it square, it will never be more than 1. So 2 divided by 1 is equal to 2. So you need at least 2k. At least 2k. 2k means double of k, double conductor material required. In compare to our DC system. So here the conductor material required is 2 divided by cos square phi times that of 2 DC system with one conductor earth. Here is one important observation is that so cos square is also important. That means your power factor is also important. If your power factor is small, that means you need more volume, you need more conductor. That's why you should try to make your power factor as big as possible. If you try to make your power factor as big as possible, that will lead you to save some conductor material. That means you can use thinner, that means smaller conductor. And this one will be 3-phase 3-wire. We do not need this single phase 2-wire. Not 2-phase. 2-phase is not required. You can read it by yourself. Now, number 9, 3-phase 3-wire system. Most important one. 3-phase 3-wire system. So here this is the Y connection transformer or the generator, whatever you think. The Y connection, Y. So this is one phase, another phase, another phase. This one will be called I9, 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 because all of them will have the same current, right? And the voltage will be one conductor to earth. That means either this one to earth, or this one to earth, or this one to earth, doesn't matter. So the system is almost universally adapted for transmission of electric power. Universally adapted means in 99% of the cases you will see this this system everywhere. This system, okay. The 3-phase 3-wire system may be star connected or delta connected. So this one can be star connected or can be delta connected. So is their wish, or it's your wish. It's star connected wire. So you can have star or delta, whatever you wish. Yeah, whatever you wish. Figure 7.12 shows the 3-phase 3-wire system, star connected system. The neutral point N is Earth. Now the RMS value per phase. Remember, this is very important. This per phase. The RMS value per phase will be Vm divided by √2. The power transmitted per phase is equal to P divided by 3, because the assumption was the whole power, the transmitted power should be equal to P. So here you have 3 phase, so power should be P divided by 3 per phase. In 3 phase the power is P, in 1 phase the power is P divided by 3. Okay, and let's get back. Load current per phase I9 is equal to P divided by 3 divided by Vm divided by 2 cos phi. Remember, these they made a mistake here. They should give another what is that bracket here. So it looks like the √2 and cos phi are multiplied. No, that is not the case. √2 is at the bottom. So Vm divided by √2 into cos phi is multiplied with Vm. Okay, so you can use another bracket here. So P divided by √3 Vm cos phi divided by √2. So the √2 will go up and 3 will come down. So √2 P 3 Vm cos phi. that is your current or load current I9. Now let A9 be the cross-section area of lines will be I9 Y3 you have three conductors. Now I9 you need to make a square. So your final line loss will be 2, obviously, because 3 square become 9. So 3 and 9 will be 3. So 2 P square rho L divided by 3. Okay, somebody wants to come. Now, line loss is 2 P square rho L divided by 3 A9 VM square cos square phi. Now, exchange the places of A9 and W. Exchange the places. So the area of cross section is equal to A9 equal to 2 P square rho L divided by 3 W VM square cos square phi. Now the volume of conductor material required, is equal to 3A9L is equal to 3 2P square rho L divided by 3 W VM square cos square phi into L. So 3 will L will become L square. So your final answer is 2 P square rho L square divided by W VM square cos square phi. So here, if you separate, now if you separate 2 and make a 4, and if you separate cos square phi, that means you will have 0.5 K cos square phi. How you get that? You multiply it by 2 here. You multiply by 2 and you multiply by 2. That means the upper one will become 4, the lower one you will have a 2. And you have a cos square phi. So 4 P square rho L square divided by W VM square. That is your K. And at the bottom, you have cos square phi and you have a 2. So that become 0.5 K divided by cos square phi. So that is actually K. Now here you can see leaf, almost less copper than your first system. And so you can understand your single phase 2-wire system is much worse than your 3-phase 3-wire system, because this system will give you a lot more saving in conductor materials, a lot more saving, because I told you the number with K, the number is bigger than 1, you need more copper. If that is smaller, you need less copper. Here it is 0.5 only, and provided that is divided by something that is less than 1. So your 0.5 will become less than 0.5. Understood? So the number of the volume of conductor material required is less. That's why it is universally adapted to everywhere. And you have another system that is called 3-phase 4-wire system. You can study by yourself. So what is the difference between 3-phase 4-wire? The middle earth position will have another line that will be called earth. That will be called earth, or that will be called neutral. Okay, here. Now this system must be Y connected. You cannot make a delta connection here. Previously you could have make one delta or Y, but here you cannot make a delta, because delta has only three connections, or 3 lines, 3 points. This one must be a Y connection. That is the only difference. Okay, you can read it by yourself. Now there is another comparison of the conductor material in underground system. The everything, the thing we have learned earlier, they are actually the same, because the overhead line and the underground line, they're actually same. One at the overhead, one is at our, one is over our head, another one is under our leg. That's why that is the only same. So that's why we will not talk about that.
So السعيد معلك مية
الو
السعيد
ساعة معلك ما بحسب ما عايز
والله ما كان معلك هنا ما له فتحين اليوم
in one table, that means for overhead line and for underground system, you can see the same maximum voltage to earth, same maximum voltage between conductors. Okay, now here you have DC system. This is 2 wire, that is 1 means 1k. The 2 wire midpoint earth is k divided by 4, right? Remember it was k divided by 4, so it's 0.25. Then we have done the single phase 2 wire system, that was 2 divided by cos square 5. K, obviously there is k, but we will not write the k. Here is just comparison. The next one is 3 wire 3 phase system, right? 0.5 divided by cos square 5 k. So if this is the comparison, whole comparison in one table, so you can understand which one you will go for. So if you use 3 phase 3 wire, it is 0.5 divided by cos square 5. If you use 3 phase 4 wire, it is not that big. It's 0.583, 0.5 and 0.583. It is not that big. You can even use this one as well. So 3-phase 3-wire and 3-phase 4-wire, these two are the most common, because 3-phase 3-wire used for transmission only transmission, that means from one place to another place. And 3-phase 4-wire system is for primary distribution, that means from area to area, because if you go to the road, you will see there are 4 wires, 1, 2, 3, and 4. That is actually 3-phase 4-wire system. You will see, if you go to the road, you will see there is 4 wires. There are 4 wires, 3-phase 4-wire system. And if you go to the highway means where the cables are used for transmitting the power from the power station to the city. You will see there are 3 lines. So 3 lines means 3-phase 3-wire, 4 lines means 3-phase 4-wire. Okay. So this is the comparison. Okay, I'm going to zoom, and we will do a math today. $250. We will do a math today. Important math. This is the math. Math number 1, example 7.1. Remember, this course carries 70% math, or at least 60% math. In your entire transmission and distribution course, you will have 60 to 70 math. So this is the beginning. So example 7.1, what is the percentage saving in feeder copper if the line voltage in a 2-wire DC system is raised from 200 volt to 400 volt for the same power transmitted over the same distance, having the same power loss? Okay, who is doing that? Don't do it. Okay. So what is the percentage saving? Remember, what is the percentage saving? Okay, first of all, clear. They said, what is the percentage saving in feeder copper if the line voltage in a 2-wire DC system is raised from 200 volt? Remember, this is one important thing. So you have 200 volt, then it will be increased to 400 volt. Increased means, so you will increase the voltage. Previously, the voltage was 200 volt. Now you want to increase the voltage to 400 volt. What will be the saving of conductor material? That means feeder copper. So কতটুকু বাঁচাতে পারবা? How much you can save? How much you can save the conductor material? Because in the previous classes, we have told, we have seen that if we increase the voltage, the conductor material cable, you can use thinner cable, right? So let's see how much copper we can save. First of all, solution number 1. This is the number 1 system that has two. What is that? That has 2 conductors. One is outgoing, another one is incoming. So I1 and I2. And the voltage between them is 100 volt, and they are written as I1, V1, and I1. Why? Because they are all for the number 1 system. Second one, when we increase the voltage, that become V2, I2, and I3. Because you have to understand, if you increase the voltage, your current becomes smaller, because that is the power. Because for the same, they have said same power transmitted. That means your power remains same. That means if you increase the voltage, your current will decrease. So let's say for 200 volt system, your current is I1, your power is P, your voltage is V1, and your cross-sectional area is A1, and your volume is V1, right? For the second system, your voltage is capital V2, your current is I2, your volume is small v2 and your area is small a2, right? Now it's pretty simple. Clear everything?
Yes, sir.
Okay. Stop it. Now it is pretty simple. We'll go come back, come down. Now here, look at this. Now your P for your first system, P is equal to V1 I1 for first system, V1 I1. Now your V is 200 volt. We know it, right? For the second system, P is equal to V2 I2. Why both of them are P? Because the same power. That's why there is no P1, P2. They are same. V2 I2. Your V2 is 400 volt. Now, since the power are same in both cases, so your 200 I1 and 400 I2, they will remain same. So take the 400 at the bottom of 200. So your I2 is equal to 200 divided by 400 I1. So your I2 is equal to half I1. That means if you increase your voltage double or twice, your current will become half. That is a pretty straightforward thing, right? Your I2 is equal to 0.5 I1. Now your power loss in 200 volt system W1 is equal to 2 I1 square R1. It's pretty simple because you have two wires. That's why 2 I1 square R1. For 400 volt system, your power loss is 2 I2 square R2. That means 2 into 0.5 I1 square into R2. Here you will put the value of I2 like this one. The value of I2 here. So square will become 0.25. So 2 and 0.25. If you multiply, your final value is 2. Your final value is 0.5. 0.5 I1 square R2, right? So that is what you got. Now we know as the power loss in the same in the two cases will be same because it is in the question. They said same power loss and the same power transmitted. Since the power losses are same, so your 2 I1 square R1 and 0.5 I1 square R2 will be same. So this is the thing. So your I1 square and I1 square are gone. So you have R1, R2, 2 and 0.5. Take the R1 at the bottom of R2. Take the 0.5 at the bottom of 2. So R2 divided by R1, 2 divided by 0.5. So you will have 4. So R2 divided by R1 is equal to 4. Now what is this actually? This is A1 divided by A2 is equal to 4. How we got that? Remember, your R2 here you have R2, here you have R1, right? Now if you multiply, or if you just put the formula of R2 and R1 like this. What is R? R is actually rho L by A, right? Now for R2 it is A2. Here you will have rho L by A. Your A is A1 here, right? So R2 is rho L by A2. R1 is equal to rho L by A1. So rho gone. Your L is gone. So what you are left with? You are left with 1 by A2 divided by 1 by A1. So A1 will go up, A2 will come down. So finally you will have A1 divided by A2, right? So R2 divided by R1 is equal to A1 divided by A2. That is your final thing. So A1 divided by A2 is equal to 4, right? So this is how you got this. Now we can multiply L in both sides. We can multiply L. So multiply L, right? Now multiply by 2 because you have 2 wire. 2. So 2LA1, 2LA2. So what you got? You actually got V1, 2AL is equal to V1, 2AL is equal to V2, right? So this one is actually your V1, this one actually your V2. So V1 divided by V2 is actually 4. So V2 divided by V1 or whatever, you can use whatever you want. Here they use a different type of method. I do not want to use that method. I want to use my method. You see, from here, from this part, we do not need. From this part, apply this method. So here you have V1. Take the V2 and multiply with 4. So V1 is equal to 4 V2, right? So V1 is equal to 4 V2. Keep it like that. Now percentage of saving, this one. Percentage of saving is equal to V1 minus V2 divided by V1. So your formula will be V1 minus V2. Okay, what is this formula? It's formula, the old formula. Old minus new divided by old. V1 minus V2 divided by V1 into 100%. Right? Percent. You have to give a percentage here. Percent. So here, put the value of V1, 4 V2 here. So what you are left with? Remember, if you put 4 V2, this is 4 V2 actually, minus 4 V2 divided by, again, 4 V2 into 100 is equal to 3 V2, and you have 4 V2. So V2 will be gone. So what you are left with? You are actually left with 3 divided by 4 into 100%. So 3 divided by 4 is equal to 0.75 into 100% is equal to 75%. So how much you can save? Actually, you can save 100%. No, you can actually save 75% of your copper, 75% copper, right? So you can actually use these or my method, doesn't matter. Both of them will be same. You can save 75% of copper. So that's all for today. This math is very important. Normally comes in every exam. I'm telling you that. But this time I do not know what will happen. So you should study, right? I think you should study. And if you think you want to share something, you can share something. Want to share something?
The last class.
Okay, next class will be Saturday.
Sir, I want to ask you one question about last class.
Okay, tell me.
Sir, in
okay, Muraz, wait. I'm going to mute everyone except you. Yeah, Muraz, tell me.
Sir, one question about when transmission is by overhead system.
Yeah.
You say, sir, there is the maximum disruptive stress. So that was the mean of disruptive stress.
Again, tell me again.
When transmission is by overhead system, the maximum disruptive stress exists between the conductive and the earth. So what's the meaning of disruptive stress?
Okay, do one thing. I do not understand your voice. It is getting affected by noise. Do one thing. You write it in the chat, okay?
Okay.
Or in the Facebook group. I will give you the answer.
Okay.
And we have another chapter called underground system. So if you have any question regarding underground system, we will learn later, because there is a whole chapter 11 is underground system. Okay,
Yes, sir.
write in the chat book, in the Facebook chat, I will give you the answer, because I
Okay.
do not understand your voice. Maybe something is gone.
Okay.
Okay, see you in the next class. Anyone has any question? You can ask any question in the Facebook group, chat group. Okay, no problem.
Okay, sir.
Okay.